So this is about logarithms. You're supposed to learn logarithms in Algebra 2. Hopefully you did. You definitely learned about them. And did you remember them? I don't know. Do we remember logarithms? We're about to find out. So here we go. We're starting. Okay. Excuse me. So the key here, guys, is that logarithms are inverse of exponents. All right, that's the whole idea. So if you have like 2 to the power of something equals another number, you can convert that into a logarithm. And that's what that little box is telling us. It's telling you x has to be positive and all that. That's fine. But look at the equations, please. Y equals log base b of x. Remember that little number is called the base? Right? Y equals log base b of x. And if that's the case, then that's the same as that base b to the y power equaling x. What does that mean? All right, so again, log base b of x equals y, and that same base b to the y power equals x. That's the form you need to adhere to. That's the form you need to get correct. If you look at this, look at the logarithm, please. The answer in the logarithm is the same as what in the other equation? Anybody answer, please? The answer to the logarithm is the same as what in the b to the y equals x equation? Exactly. That's the key to life right there. Okay, so make a note of that when you write these down. The answer to a logarithm is always the exponent. Okay, the answer to a logarithm is always the exponent. Okay, that's what you really need to understand when you're doing this. Okay, so be aware of that. Make a note of it, and we'll move on here in a minute. But again, log base b of x equals y. That means b to the y equals x. That's the key to life here. All right. All right, it says evaluating without a calculator. Let's evaluate log base 2 of 32. Let's go to the board in a second. Log base 2 of 32. All right, log base 2 of 32. Okay, so all a logarithm means is the exponent that gets you from here to here. So here you could probably just think about it and get the answer. I'm just going to write it out the long way just so I can show you something. But again, all the logarithm means is what power do I raise this to get to that, and that is my answer. Remember, evaluating means get an answer. All right, so I'm just going to show you something just for the idea. All right, if we just say that equals x, we don't know what it equals, so we'll call it x. Remember, base to the power of what's on the other side. That's the form. If you look back at the note you just wrote down. So 2 to the x power equals 32. All right, now I just want to show you that these are equivalent. These mean the same thing. Okay. So that's what you need to understand. So you're just asking yourself on this question, what power do I raise 2 to raise 2 to what power to get 32, right? So, well, 2 times 2 is 4. That's the second power. Times 2 again is 8. That's third power. Times 2 again is 16. That's the fourth power. Times 2 again is 32. That is the fifth power. So the answer to this question, log base 2 of 32 equals 5. Okay, hopefully that makes sense to you, and we'll move on here in a minute. But again, base to the power equals the value on the inside of the log. So you're always asking yourself, what exponent will give me that answer? Okay? And this should work. I played with it last time. So the answer there is just 5. Boom. All right, who just showed up here? Jacob, good afternoon. Brian, good afternoon. All right, moving on. All right, you have 5 logarithms here. Please knock those out. They go from very easy to a little bit more difficult. Give them a shot, please, and we'll do them all on the board here in about a minute or two. But go ahead, and you got 5 logarithms to do. Please tell me when you are completed. Thank you, Joseph. Thank you, Christian. Thank you, Jacob. Sam. Yeah, you may have some questions on the bottom ones, but if you got as far as you could, then just we'll go over them together here. All right, go about 10 more seconds. All right. So on the first one, right, you're just asking yourself 3 to what power is 81? So you may know this off the top of your head. You may need to think 3 times 3 is 9, times 3 again is 27. 27 times 3 is, in fact, 81. So that's 3 to the 4th power. That's all you're saying there. All right, this one's probably even easier, right? 5 times 5 is 25, times 5 again is 125. So 3rd power. Okay. Now, the next one where it gets a little more tricky, and maybe you have it out there, maybe you don't, though, and it's okay if you don't, but let's make sure we go through this one. So we're going to say log base 2 of 1/8, right? So we're saying, okay, this is the same as 2 to the x equals 1/8, okay? Why does that help us? That doesn't help me at all, you might think. Well, it does if you can get your base values the same, okay? So the question you're asking yourself is, to what power, or how can I write 8 as 2 to a power, right? Can I make 8 2? I can, because I know 8 is really just 2 cubed. So what I can do is I can say 2 to the x equals 1 over 2 cubed. Why does that help me? Well, watch. Because now I know I have 2's in both spots, but one's in the numerator and one's in the denominator, right? We want to get them to be in the same level, on the same level. So we're going to think to ourselves, what causes a term to move to the denominator? Okay, what causes a term? What kind of exponent? Well, we talked about this earlier in the chapter, right? We know a negative exponent causes it to move to the denominator. So what do we do with a negative exponent? Well, we say, so that's 2 to the x equals 2 to the negative third. Okay, 2 to the x equals 2 to the negative third. And now we just use a little bit of common sense, right? So we say, okay, well, these are the same, right? 2 to this power is the same as 2 to that power. If the 2 powers are the same, then, or excuse me, not 2 powers, excuse me, but 2 base values, I misspoke there, 2 base values are the same, we know the powers must be the same. So we're done, right? Because x just must equal -3, and we are done with the problem. Okay? Now, again, you don't have to write that all out, but that's one way to do it, especially sometimes it gets a little more difficult, and you might want to see it. Right, any questions on that one? All right. Thanks, Christian. All right. So that's what we're doing there. Thank you, Cece. Taylor, thank you. Okay. Let's move on to the next one. So I'll try to keep that up there for a second if anybody needs it. So log base 1/4 equals 16. Log base 1/4 equals 16. So we're going to say it again, the same idea. 1/4 to the x equals 16. Okay, 1/4 to the x equals 16. So again, you're going to ask yourself, how can I make these base values the same? Well, technically you could break 4 down even further, but we don't need to, right? Because I can make 16 4 very easily. So I'm going to make 16 into 4 squared. Like that. Okay, now I'm in the kind of reverse spot I was last time, right? The last time I had a 2 on the bottom over here. Now I have 4 on the bottom here. Well, it's the same rule. The same exact rule, right? So that's really 4 to the negative first. Okay, so hopefully everybody has this by now. That's really 4 to the negative first. So I have the negative first to the x equals 4 squared. And this comes back to basic exponent rules that you learn in Algebra 1. If you raise a power to another power, okay, power to a power, you multiply, right? You multiply those. So really, this is really the same as negative x, 4 to the negative x power, okay? So we have 4 to the negative x equals 4 squared. All right, so we did it. We have the same base values. We're now going to set the powers equal to each other. That doesn't quite give us our answer. It's very, very close, right? It's very close, but it doesn't quite give us our answer. Negative x equals 2. Okay, so in that case, I know that I have to divide by negative 1. So x equals negative 2 is our answer there. Okay, all good there? So you get creative there, Christian. Thank you, Kayla. All right. The next one is actually very easy as long as you know how to deal with rational exponents. So we're going to say log base 3 of the square root of 3, right? And you already have the same base, right? So all you need to do to think about this is what is, again, we can write it out if we want. It looks like that. But how do we write this as an exponent? Well, we talked about this already. Not today, of course, but we have talked about it. That's just the square root of x, right? That's x to the 1/2 power. All right, so just like that, I have the same base, so I can drop the base. X equals 1/2, and I'm done. All right, so those were your answers there for that little section. Any questions? All right, so once again, we had 4, 3, negative 3, what was that, negative 2, and 1/2. Okay. And Mope is back. All right, let's move on. We're up to 15 people. Who have I not seen? Hello, Harmony, Nikki, and Tyrese made it in. All right, good stuff. And a phone number, whoever the phone number is. Tyrese getting all the fan support here. Yeah, I guess we don't have Alyssa for your back corner there, guys. All right, moving on. Just a couple rules that we'll talk about very quickly here. These are logical if you've understood the first few minutes here. The first one says log base b of 1 equals 0 always. If you ever have 1, the answer is 0. Why is that? Because we know anything to the 0 power equals 1. All right, so you might want to jot that down. The next one says log base b of b equals 1. Of course it does, right? Because if you have the same base there as the value inside, the exponent is just 1. That's the answer. Log base b of b to the y equals y, again, because the exponent is the answer. And the last one's a little ugly, but it makes sense. B to the log base b of x equals x. If you write that out, that means, again, log base b of x equals log base b of x. Jot those down just so you have them. Good little thing to have. Tell me when you're done writing, please, but not a huge deal, just some good things to have in your notes as you take that academically integrity-laced quiz. Thank you, Cece. Thank you, Christian. Thank you, Kayla. Wadley. Didn't even see you in there. Yeah, write those down, love. Thank you, everyone that's responding. Hello, Harmony. Thank you, Nikki. All right, we look like we're pretty good here. All right, let's move on. All right, so a couple things here. First is called a common log. The base is always 10. So anytime you see just the word log, that is a base of 10. All right, anytime you see the word log, that's a base of 10. If you look at your calculator, it says the word log. Base is 10. All right, anytime you see log without a base, the base is 10. So before we start, just in the text box, please somebody answer. Log of 100 is obviously what? If I'm taking 10, I just need to know the exponent there. So what exponent am I going from 10 to 100, obviously? Sebastian wins the race. All right, 2 is the answer. So we're simply saying 10 to what power equals 100. All right, so very, very simple stuff. That's the deal there. So you should only need about a minute here, guys. You have 2 problems to evaluate. Again, without your calculator, please. Log of the 5th root of 10 and log of 1 over 1,000. Please knock those out. Fifth root of 10 and 1 over 1,000. As always, our new always, tell me when you're done, please. The new normal, as they say. Thank you, guys. I think, yeah, probably want the E in there, I would say. First one kind of looks like Donzo, so I think the E gives it the Dunzo sound. Thank you, Brian. I missed Kayla up there and Sam. Thank you, guys. Thank you, Sebastian. Thank you, Devin. Thank you, Cece. Thank you, Nikki. Thank you, Joseph. All right, I think we're ready. So log, remember our base is 10, so we're talking about what is the exponent here. Very, very simple, right? It's the inside exponent divided by the root of the radical, right? So the inside by the root, so that means we're just saying 1 over 5. That's all we got there, okay? 1 over 5. And here we're saying, again, 10 to what power equals 1 over 1,000. Again, you don't have to write it out. But if you want to, you can. It looks like that. I lost my video. So much for that. Well, we'll go audio here for a second before I reset. This always happens, but it's okay. So we'll just write the answers in here. We have, this one was 1/5. Just kidding. 1/5. And this one here, we're now saying what power, basically 10 to what power is 1,000. It's a third power. It's on the bottom, right? So we're going to say -3. That is it. Any questions there? Yeah. I'll hit the next slide, and then I will reset my video, because, again, this always happens. So you have 2 problems to do here. This should take you a very short amount of time. All you need to do to get these answers ready to go to solve for x is to change the form, what we've been doing, the last 15, 20 minutes, right? Changing the form. So you should have these answers by the time I refresh and get back. Goodbye. I'm back. Are we done? Good. All right, guys, all you're doing, and I'll kind of just say this out loud. I don't think I need the board, right? You're just saying, I'm changing the form. So if you look at A, the form is the base to the powers on the other side, right? So what's the base on A? 10. 10 to the third equals x. That's the whole problem. And we know that 10 to the third is 1,000. So the answer to A is 1,000. Right? 10 to the third equals x. That means you have 1,000. And on B, you're raising the same thing, base to the power, so 2 to the 5th power. 2 to the 5th power, of course, is 32. And you're done. So the answer to A is 1,000. The answer to B is 32. Any questions? Easy day today, right? This would be one of those classes where you would have had a lot of time to do your homework in class in the good old days. R.I.P. the good old days, man. Maybe. All right, guys. Only a little bit left today, but let's knock it out. So the idea of a natural log has a base of e. We talked about e a little bit, I don't know, last week sometime, Monday I think it was. Remember, e is like pi. It's a decimal. It's 2.718 something. And all you're doing with a natural log is taking a base of e. This is actually really valuable in calculus. You get into this a lot more in calculus, anybody that's moving on. But for us, we just got to get the basics. So all we're talking about is the natural log, which is log base e. All right, log base e. You should have that in your notes. And again, nothing is different. ln means log. It just means with a base of e. All right, so in your notes, you should have ln x equals log base e. Okay. All right, so with that being said, this is super quick. Super quick. If you have an understanding of what natural log means, like we just said, you should be done here. Honestly, guys, this is a 30-second problem, maybe a minute at most set of problems. Pay attention to your rules. Tell me when you're done, please, and we'll go from there. Thank you, Christian. Thank you, everyone that's responding. All right, we should be about done here. Thank you, Cece. Keep working if you need to, but I'll start typing. So again, we saw one just like this, right? Log base e of the square root of 3. This is ln of square root of e, ln log base e. The e's match up. We look for the exponent. That is 1/2. All right. And then for basically log base e of e to the 5th, we know the answer is the exponent, right? So we just get 5. And now this last one, we saw this in the notes earlier. If you have the same base as the in the logarithm as the base of the exponent, meaning e to ln of 4, meaning e log base e of 4, those cancel out, and the answer is just, oh no, I lost my text box. The answer is 4. Maybe. There it is. Okay. Very, very simple stuff. Very, very simple stuff. Okay, we're moving on. I'm assuming everybody's good with that. Oh no, Sebastian, what were you doing? Thought you were yelling. I was overthinking it. Were you not yelling? It's okay. Caps lock away, man. All right. So we are just about done. Let's quickly talk about the idea of a log graph. So that's the graph of ln of x right there. And remember what I told you at the very beginning, guys? This is the inverse of exponential, right? So an exponential graph goes up forever, goes up forever. And this one does not. I mean, it does go up forever. Technically, it's still rising, but it's rising very slowly. What I'd like you to do, just for a minute here, guys, is grab your calculator if you have it. In y1, graph this one, ln of x, and in y2, graph e to the x. All right. So in y1, graph ln of x. In y2, e to the x. And I just want us to look at them together for a minute. It's not anything crazy. So again, y1, ln of x, y2, e to the x. All right, so it should look something like that. And I just want you to think about it for a minute. They're inverse of one another, right? So that's why they kind of are facing the opposite way. They reflect over that middle line, y equals x. But here's the idea, right? If you look at this, this has a horizontal asymptote, the red one, which is e to the x, has a horizontal asymptote at 0. If you look at the log graph, it has a vertical asymptote at 0, right? So the x and y have flipped. That's the whole idea of inverse. So again, this is e, but let's just take a random number. If you have like 2 to the 3rd power, right, you get 8, right? So that means if you plug in 3, you get 8 to 2 to the x. Well, that means log, you plug in 8 to get 3, right? They're inverse. If you plug in 4, you get 16 normally. Well, now if you plug in 16, you'll get 4. So they're completely flipped. That's why the exponential graph shoots up so quickly and the logarithm graph goes slowly, but it is still going up eventually. And again, they're inverse of one another. All right? Hopefully that makes some kind of sense. Just make sure you have a log graph in your notes so you know what it looks like and everything like that. All right? And guys, we are basically done. That S was supposed to be on the top line, but I don't really feel like going through transformations with you. If I tell you that, you have to graph ln of x plus 3, well, on the inside, right? Well, that means plus 3 means left 3, of course, right? If it's plus 3 on the outside, it means up 3, okay? So we've seen transformations a million times. It'll come up in the assignment maybe, but I don't really feel any need to discuss transformations. I think you agree. All right, so with that being said, we're done. So you have a homework assignment, or whatever you want to call it. Everything's home. So you have an assignment to do. It's unlocked already from 3.3. Shouldn't take all that long. Make sure, by the way, some people, I'm not saying it's the 16 people in here or not. Some people have not turned in the 3.2 assignment yet. Make sure you get that in. If you ever happen to miss an assignment and it's locked, the 3.2 one's still open, so you're fine. If anytime it's locked, just submit it with the next one. Like, just label it in the next one if you ever get lost there. All right, but that's the deal there. Quiz on Wednesday. Again, our video on Wednesday will just be a quiz review. Okay, our video on Wednesday will be a quiz review. You'll have a take-home quiz to submit for the following Monday, which will be a quiz grade. So we're going to try again. I want my grade book to look exactly like last year's did. Like last year's fourth quarter should look exactly like this year's fourth quarter. That's the way I'm planning. Quizzes and tests and everything exactly the same. So make sure you take that seriously. If you need help, come in here on the video and we'll go through some questions and whatever you guys need. Other than that, I am done. If you have anything to say or questions or comments or anything, throw them out there now before we break. You're very welcome, Christian. Appreciate that. You too, CC. Got a little AP Calculus BC coming next.